So this is the third sum that we'll be considering for the chapter on circle. So let's read the sum first. In the figure, A, B, C are 3 points on a circle. So as I mentioned before, I always like to tally my data, theoretical data, with my visual representation of the sum. So A, B, C are 3 points on the circle. So that matches. The tangent at C meets BA produced at T. So BA is a line segment that joins the point D on the circle and the point C on the circle, and that point BA has been extended to some point T. The position of T as such has not been mentioned, but we can realize that T lies on the extended portion of BA, where BA has been extended on the side of A. And the tangent at C, so they have said that C is a tangent. So what we can do is, if I join OC, then OC will be perpendicular to CT. So the tangent at C meets BA produced at T. Next is, given that angle ATC equals 36. So we have angle ATC given to be 36 degree. Angle ACT is 48. So angle ACT, this angle is 48 degree. Calculate the angle subtended by AB at the center of the circle. So what we need to find is the angle that this line segment AB subtends at the center of the circle. So we essentially need to find the value of this angle. So let's go step by step. This is also not a very difficult sum. It's just what you need. It's basically the approach of the sum. So let's first take triangle ACT. So this is the triangle that we have under consideration. We know that the sum of 3 sides of a triangle is 180 degree, and for this triangle ACT, we already have been given angle ACT equals 48, angle ATC equals 36. So going by the theorem of the fact that the sum of 3 sides of a triangle is 180 degree, I can find the value of CAT. So that is what I have done. I have done CAT equals 180 degree minus angle ACT, which is replaced with 48, minus angle CTA, which is replaced with 36. So this angle 48 represents ACT, and this 36 represents CTA. So that is what I have done for this part. And if you do this calculation, 180 degree minus 48 degree minus 36 degree, you end up with 96 degree. So I find CAT is essentially 96 degree. Next, what I do is, I know OCT is 90 degree because by definition, CT is the tangent to the circle which has its center. I have named the center of the circle as O. So this is my naming. This has not been given in the sum. So let me just mark it separately. So going by the definition of a tangent of a circle, OC being a radius of a circle and CT being its tangent, OC is perpendicular to CT. So obviously angle OCT is 90 degree. And I had already got from the data that angle ACT is 48 degree. So angle OCA will be 90 degree because this total part is 90 degree and this part is 48 degree. So naturally OCA will be 90 minus 48 degree, which turns out to be 42 degree. So this is 42 degree. Now, if I consider this triangle OCA, OC is a radius of a circle as well as OA. So you can't have, again, as I have mentioned before in my previous video, you can't have 2 radii or radii of 2 different lengths for a single triangle. So naturally OC equals OA. That is 2 sides of the triangle OCA are equal, which essentially means that OCA is an isosceles triangle, and we know that the angles which are adjacent to the 2 equal sides of an isosceles triangle are equal. So that means if OCA turns out to be 42 degree from here, then the other equal side angle would be OAC, which implies OAC should be 42 degree as well. So that is what I've written here. OC equals 42 degree implies that OAC is also 42 degree because OCA is an isosceles triangle. Next, what I do is, you know that an angle on a straight line is 180 degrees. So I know that this portion is 180 degrees. So let me just mark that here. So BAT, that is not essentially an angle, but we can say that this portion creates 180 degree. And I already know this segment, this portion OAC is 42 degree, CAT is 96 degree. So the remaining OAB would be 180 minus 96 minus 42. So this 96 represents CAT and this 42 represents CAO. So that's OAB is 180 minus CAT minus CAO. So that's 180 minus 96 minus 42, which again turns out to be 42 degree. Going by the same logic as I did for triangle OAC, OBA also turns out to be an isosceles triangle because they have OB equal to OA, which is the radius of the circle. And naturally, OAB will also be equal to OBA. So this angle is again equal to this angle. So since we already found out OAB is 42 degree, that is what we found out, then that naturally means OBA will also be 42 degree. Now again, this triangle is a triangle has the sum of its angles to be 180 degree. So the final step that we have is for triangle OBA, BOA will be 180 degree minus 42 degree minus 42 degree, that is 180 degree minus twice of 42 degree, and it turns out to be 96 degree. So essentially angle BOA turns out to be 96 degree. So that is how we do the sum. This sum also does not require a lot of knowledge per se, for as in rigid definitional knowledge, but this sum essentially has a lot of calculations. So you find this, you find this, then you find this. There's a lot of layering. So the first sum that we did had some amount of theory, that is some amount of theorems pertaining to this chapter and some calculations. The second sum that we did was primarily theory. In fact, it did not have any calculation. It essentially had zero calculation whatsoever. And this had a little bit of additions and subtractions, not much. And essentially these three sums cover the typical sums that come from the chapter of circle.